Hello students, in this video we are going to discuss numerical problem number 8 from the chapter of torque on a current loop and moving coil galvanometer from Nootan ISC Physics. Students, the question says that we have been given a moving coil galvanometer which has got 24 turns and has a resistance of 12 ohm. The question asks us by how much the number of turns should be increased so that the current sensitivity of the galvanometer increases by 25%. And if in doing so the resistance of the coil now becomes 20 ohm, what will be the effect on the voltage sensitivity? So there are two parts of the question. So let's begin with the discussion of this particular numerical problem. But before starting with the numerical problem, let me make these two terms very clear to all of you. One is current sensitivity, another one is voltage sensitivity. तो बच्चों सबसे पहले इस बात को समझते हैं current sensitivity क्या होता है. तो current sensitivity is defined as the deflection produced per unit amount of current flowing through the galvanometer. So it is the deflection produced per unit of current flowing through the galvanometer, or more appropriately you can say or ammeter. Similarly, voltage sensitivity is defined as the deflection produced per unit potential difference applied across the galvanometer, or more appropriately you can say it as or voltmeter. So that is how you have defined the current sensitivity and voltage sensitivity. Mathematically, when you are going to go for the theory of the moving coil galvanometer, then you will come to know the current sensitivity has got an expression of NAB upon C. So I'm not deriving this expression, I'm just using the formula. If you want to go into detail, you can refer to the book of class 12th or something of the similar level. Any book will tell you how this expression has come up. But here I'm just going to use the expression or the formula itself. Here N happens to be the number of turns of the coil of the galvanometer. A happens to be the area of the coil, and B happens to be the magnitude of the magnetic field in which the coil is placed. Now this C is referred as torsional constant, बच्चों. And it measures the torque required to produce any deflection in the wire. So this is a torsional constant of the wire. And what does it measure? It measures the torque required to twist द वायर। किसी भी तार को ऐंठने के लिए मुझे कितना टॉर्क की जरूरत है। कोई तार है, अगर तार को आप ऐंठना चाहते हैं तो उसको ऐंठने के लिए कितने टॉर्क की जरूरत पड़ेगी, वो टॉर्सनल कांस्टेंट उस वायर का डिसाइड करता है। तो बच्चों ये फॉर्मूला है आपके पास करंट सेंसिटिविटी का। अगर मैं वोल्टेज सेंसिटिविटी को देखूं तो वोल्टेज सेंसिटिविटी बाय डेफिनेशन वाज फाई अपॉन वी, और अगर तुम थोड़ा ध्यान से देखो तो फाई वी कैन बी रिटन एज आई आर ओम्स लॉ की मदद से। अब देखो बच्चों ये फाई बाई आई जो है वो क्या हो जाएगा, करंट हो जाएगा, करंट सेंसिटिविटी हो जाएगा। तो करंट सेंसिटिविटी और वोल्टेज सेंसिटिविटी में एक रिलेशन आ जाता है यहां से, एस वी इज इक्वल्स टू एस आई बाई आर। ठीक, और इसी के साथ साथ अगर मैं इसमें एक स्टेप और आगे बढ़ जाऊं और इसमें एस आई की वैल्यू सब्सटीट्यूट कर दूं तो आपको पता चल जाएगा एस वी इज इक्वल्स टू एन ए बी अपॉन सी टाइम्स आर। ठीक, तो ये एक्सप्रेशंस, ये फॉर्मूलेज आपको इस न्यूमेरिकल को सॉल्व करने में बहुत यूजफुल होंगे। सो इनको ध्यान से नोट कर लीजिए, अपने दिमाग में भी रख लीजिए, एंड दैट विल हेल्प यू to solve this particular numerical problem. Now let's move for this particular numerical problem. Let's try to understand how this numerical can be solved. As we now know, what do we mean by current sensitivity or voltage sensitivity for any galvanometer? Let's try to proceed to solve this particular problem. So current sensitivity has an expression of NAB upon CR, NAB upon C, where N is the number of turns. So according to the question, the number of turns that the coil has is 24. The area of the coil is not known to us. Let's assume it to be A. The magnetic field in which the coil is suspended is also not given to us. Let me call it as B. And C happens to be the torsional constant of the wire by which this coil is suspended, and let's take it as C. So this becomes my equation number 1 for current sensitivity. Now what we are doing, we want to increase the current sensitivity by 25%. So let's say the initial sensitivity SI was equal to X. So this is my initial sensitivity X. So X is equals to 24 AB upon C. Now what you want? You want this current sensitivity to increase it by 20%. You want this current sensitivity to get increased by 25%. So initially it was X. So now you want the current sensitivity to be 1.25x. So the current sensitivity is now increased by 25%. So how many number of turns should the galvanometer now has? So I don't know the number of turns. Let me mark this as N dash. But it is the area of the coil I am not disturbing, so the area of the coil still remains A. Magnetic field in which the coil is suspended still remains as B, and the torsional constant of the suspension wire also remains C. So this becomes my second equation. So I am just changing the number of turns from 24 to some N dash, so that my current sensitivity gets increased by 25% and now becomes 1.25x. So these two equations are there. What I'm going to do, I'm going to divide these two equations side by side, and once I divide this equation side by side, this x and this x goes off, AB by C goes off. So this becomes 1 upon 1.25 is equals to 24 upon N dash. And solving for N dash will be equals to 24 into 1.25, which is equal to, N dash comes out to be 30. So what I need to do, in order to increase its current sensitivity by 25%, I have to increase the number of turns from 24 to 30. So that is the answer to the first part. Now what the second part says, the second part says that while doing all these things, the resistance of the galvanometer gets increased by 20 ohm. So initially the resistance was 12 ohm, isn't it? The new resistance now becomes 20 ohm. So let's see what was how these two things comes in play the role. So initially, let's call let's say that the voltage sensitivity SV was equal to SI upon R, and what is initial current sensitivity? We have assumed it to be X, so the initial voltage sensitivity will be X upon, and what is the initial resistance? That is 12 ohm. This is my equation number 3 now. And once the current sensitivity is increased, okay, the resistance also got increased, so does the voltage sensitivity would also change. So I'm putting the new voltage sensitivity is SV dash is equals to SI dash upon R dash, isn't it? Therefore SV dash will be equals to, what is the new current sensitivity? That is 1.25 times of the initial sensitivity, current sensitivity. So 1.25x. And what is now the new resistance of the coil? The new resistance of the coil has become 20. So this becomes my equation number 4. So let's compare these two equations and try to solve it out. So now friends, what I'm going to do, I'm going to divide this equation number 3 and 4 side by side. So SV dash, SV upon SV dash will be equal to X upon 12 divided by 1.25x upon 20. This X and this X cancels out. So SV upon SV dash is equals to 20 upon 1.25 times of 12. Okay, I hope that's clear to all of you. What I have done, I have just brought this 12 in the denominator of this, and this 20 goes up in the numerator. Now solving it out. So solving out, this point goes, 100 comes, 25 5s are, and 25 4s are, 5 4s are, and 4 3s are. So or SV upon SV dash comes out to be 4 by 3, or SV dash is equals to 3 by 4 times of SV, or simply SV dash is equals to 0.75 of SV. Now what does it mean? That the new voltage sensitivity is 25% is smaller, 0.25, 75.75 नया बन गया ना. So new voltage sensitivity is 25% times smaller than earlier voltage sensitivity. So you can conclude that the new voltage sensitivity is now 0.25 times lesser than the original voltage sensitivity, or 25% smaller than the voltage sensitivity. I hope this would give you an insight to understand how to solve these type of particular numerical problem. Friends, if you have found this channel to be useful for you to understand different numerical problems and help you to solve other numerical problems based on ISC board, I would like you to give a like and share these videos with your friends and classmates, and please do not forget to subscribe to this channel.